Okay, so we're working on our module two review. So we're going to answer another question that's going to help us to answer about scale factors. And we're talking about the area of a scaled image. So if we go back to what we remember about scale factors, remember there's a formula that we use, which is our scale over the actual is going to be equal to K. Okay. And remember that K represents what we've done to the scale. If we have enlarged it, decreased it, reduced it, it just tells us what's going on with it. So if K is equal to 1, then that means it's the same. Okay, we haven't increased it or decreased it. If K is greater than 1, then that means we increased it. And if K is less than 1, then that means that we reduced it. All right, so in this example, they say the following figures are the original octagon with a given area of 128 square feet and its scaled version. They want to know if the scale factor of 1/4 was used to create the scaled version of the octagon, then what is the area of the new octagon in square feet? So remember when we talked about scale factors, we have the formula here. And if we're talking about area, all we do to show that we're talking about area is rewrite the formula and we square everything, right? So everything that we are looking at should be in square units. Okay. So let's see what we know. From the story, they give us, we don't have the scale, right? That's the reason the problem exists. I'm going to put X there to let me know that that's what we're looking for. What about the actual? They give us 128 square feet, right? So that's squared. And then for K, our scale factor, it is 1/4. 1/4 means it's less than 1. So we know that they reduced it and we can tell by looking at it, right? This is the original and then this is the scale image. All right, so we're going to take the 1/4, but it is not scaled. So it's not squared. So we have to square that to make sure that we have it in the same way. So what we have is X over 128 is going to be equal to 1. When we say squared, what we're saying is 1, the base 1, is being multiplied by itself 2 times. So 1 times 1 equals 1, right? And then here we're saying 4 squared, meaning that we're going to take the 4 and multiply it by itself 2 times. So 4 times 4 gives us 16. Okay, so now we have that in the correct order. Now, when we look at it, we notice that X is not isolated. It is not by itself. So we need to figure out what we need to do to get X all by itself over here. So when I look at the problem, I see that X is here. I see a fraction bar, which lets me know that we're dividing, and I see 128. So to get rid of anything that's stopping X from being by itself, I'm going to use the inverse operation. So in this case, I'm going to multiply both sides by 128. And when I use cross multiplication, 128 divided by 128 leaves me with 1, right? 1 what? X. And then over here on this side, I'm going to do the same thing. I'm going to multiply. And so I have 1 times 128. That gives me 128. And then 16, this is the same thing as saying like over 1, right? So 16 times 1 gives me 16. Okay. And so this is what we have. And then I'm going to try to see, because remember, a scale factor, we want it in its simplest forms. Actually, we already have the scale factor, but anytime that we get an answer, we always want to make sure that we simplify it if possible. So I'm going to plug in and see, can we reduce this? So we have 128. Remember, fraction just means that we're divided by 16. Gives me 8. So X is equal to 8. And so what does this mean? This means that our scale is 8. 8 what? Remember, everything was squared. So this is 8 square feet.